Everyone, again, this is Sir Don and we are going to discuss about sets operations. So this is different from the operations or the four fundamental operations that you have seen in numbers because we will be dealing with the groups or collections or what we call the set. At the end of this discussion, you are expected to perform operations involving sets. Visualize what we're dealing with the set operations, you have to be familiar with what we call the Venn diagram. So this is named after the English logician John Venn, who lived from 1834 to 1923, who used to show relationships among sets. So here, we will be using circles that denote subsets, and we will be using rectangular regions to denote universal set. So okay, so this is the illustration of that. That rectangular region, it shows the universal set. And we have here the set, which is being denoted by the circle. Let's say we have here set A under the universal set. Before we proceed with the operations, you should be familiar with the relationships between sets. So you can recognize here the different associations or the different classifications of sets according to the groupings. Let's say, for instance, we have disjoint sets. This is the first type of relationship. This is a two or more sets having no common elements, which means these two groups are entirely different. Their members are not common to each other, which means that a member of one group is not present to another group. They are isolated, they are entirely different. So let's say, for instance, we have this universal set. We have group A and we have group B, or set A and set B. These two circles represent groups and they are not associated, they are not connected, which means they are entirely different or separated. So let's say, for instance, we have set A. As you can see, the elements are 2, 4, 5, and 8. And set B, the elements are 1, 3, 7, and 9. And there is no element which is present in set A, which is also present in set B. This group has no common elements. The second group contains common elements between two or more sets. So this is what we call joint sets. So this is two or more sets having some elements in common. So let's say, for instance, we have this universal set. The first set has these elements 3, 5, and 2. And we have also 7. So take note that 2 here is present at the intersection of these two elements. So we have set B, we have 2, 4, 6, and 8. So here, 2 is present, or this is present in the intersection of these two elements, which means that, or two sets, which means that 2 is present to set A and is also present to set B. If we're going to enumerate that one using the listing method, we have set A contains elements 2, 3, 5, 7, and set B contains elements 2, 4, 6, and 8. And we notice that 2 is present to both elements. So we can write here in this intersection. So we call this one as the joint set, which means that there are two or more elements or sets containing some elements that are in common. This is what we call the overlapping sets. This is one set can be a subset of the other, which means that all the elements present in one set are also present in the other set. So if you're going to illustrate that one, this is our universal set, and we have here set A, then set B is containing all elements present in set A. So we have here set B. Example, we have here set A 2, 4, 5, and 8, then set B is containing 4 and 5. As you notice, we have here 4 and 5, which are both present to set A and B, and there's no element in set B which is not present in set A. The different relationships among sets. So this time, we're going to proceed with the operations. Here, after performing an operation, we'll be classifying what type of relationship is existing between the sets. So the first operation is what we call the union of sets. So the symbol here is an inverted U. We have here inverted U. Okay, this consists of all the elements which belong to the given set. So let's say, for instance, we have the universal set, set A and set B. So the union of set A and B is 2, 3, 4, 5, 6, 7, and 8. What we're going to do here is that we are just going to combine all the elements present in both sets. But you're not going to write 2 here twice because 2 is already present to the 2 sets. You're just going to write it once. So again, union of sets is that you are just going to write all the elements in the 2 or more given sets. That is union of sets. Example, let's say we have the given A, set A. We have the elements 1, negative 4, 6, 5, and negative 2. And we have set B, we have elements 0, 7, 8, 10, negative 4, and negative 1. To find A union B, or the union of A and B, you're just going to write here the elements present in both sets A and B, and you're going to highlight elements that are common. Then after that, write all the elements present in the given set. So as you can see, all the elements are 1, 6, 5, negative 2, negative 4, 0, 7, 8, 10, and negative 1. So this is the answer, or the intersection, the union of set A and B is 1, 6, 5, negative 2, negative 4, 0, 7, 8, 10, and negative 1. So I highlighted here negative 4 since negative 4 is present to both elements. So I will not be writing this one twice in the final answer. Next operation is what we call the intersection of sets, or the symbol for that is the inverted U. Inverted U here. This consists of all the elements that are common to the given set. So let's say, for instance, we have the universal set. We have set A having elements 3, 5, and 2. 2, 3, 5, and 7. We have set B, elements 2, 4, 6, and 8. So as you can see, we have this common element 2. So therefore, the intersection, this is actually the intersection. The intersection is the element present to the intersection of the two sets. So therefore, the answer here is 2. This is the common element present to set A and B. For example, let's say, for instance, we have set A, x such that x is a whole number less than 5. So we will be listing here all whole numbers less than 5, and we have set B, we have 1, 3, 5, 7, and 9. So you are going to find the intersection of A and B. To find the intersection of A and B, you have to list first the whole numbers less than 5. So we have here set A, 0, 1, 2, 3, and 4. As you can see, 0 is included because 0 is a whole number. Then we have B, we have 1, 3, 5, 7, and 9. So I highlighted 1 and 3 because 1 and 3 are both present to sets A and B. So therefore, the union of A and B, the intersection of A and B is 1 and 3. If you're going to illustrate that, that will become 1 and 3 is the intersection of this. Operation is what we call the complement of a set, or in symbol that is A prime, or A raised to C, or A bar. So these are the three symbols for the complement of a set. So you will be seeing this one in different references, because there are some authors who are writing textbooks using different notations. So this is the symbol for the complement, or this one, or A raised to C, then A bar. So which means this consists of all the elements found in set U but not in set A. Which means that you will be looking for all the elements which are present in the universal set but not present in the given set. So let's say, for instance, we have the universal set. We have here 1, 2, 3, 4, 5, 6, and we have A, 2, 4, 6. So when we say A prime, you are going to list those elements which are not present in set A. So the elements present in set A are 2, 4, and 6. So what are those elements which are not present in set A but present in the universal set? Those are 1, 3, and 5. So 1, 3, and 5, which are outside the given set. Example, given the universal set x such that x is a prime number less than 10. So you will be listing here all prime numbers which are less than 10. Given set A, x such that x is an even number less than 10. So you will be listing all even numbers less than 10. So you're going to find A prime. So the universal set contains elements 2, 3, 5, and 7. Since 2, 3, 5, and 7 are prime numbers less than 10. 1 is not a prime number. List also the elements present in set A. We have here 2, 4, 6, and 8. So what we're going to look for is that we're going to look for the A prime or the complements of A, which are the elements that are not present in set A but are present in the universal set. So those are 3, 5, and 7. So as you can see, 3, 5, and 7 are not present in set A. So in diagram, you have here the universal set, and we have here set A, 2, 4, 6, and 8, and the elements outside are 3, 5, and 7. Operation is what we call the difference of sets. This is the opposite of the complement. Given two sets A and B, when we say A minus B is that the set of elements which belongs to A but not belongs to B. Wherein, we are going to look for the elements present in A but not present in B. Let's say for instance, we have the universal set containing elements we have 3, 2, 3, 5, and 7, and set B we containing the elements 2, 4, 6, and 8. So when we say A minus B, we're going to look for the elements present in A but not in B. As you can see, what are those elements found in A which are not found in B? Those are 3, 5, and 7. So I have here 3, 5, and 7. So 2 is not included because 2 is also present in set B. Have an example. Let's say for instance we have here set of multiples of 4 less than 10. Multiples of 4 less than 10, and we have set Px such that x is an even number less than 10. So you will be enumerating all the elements in A and B. So we are going to look for A minus B or the difference of A and B. So all the multiples of 4 less than 10 are 0, 4, and 8. So these are the numbers which are multiples of 4 less than 10, and we have set B even numbers less than 10. We have 2, 4, 6, and 8. What we're going to look for is that we're going to look for all the elements present in A but not in B. So the answer is 0. 0 is not present in B. Therefore, that is their difference. So in symbol, we have using the Venn diagram, we have the universal set. We have set A containing elements 0, 4, and 8. And we have here the intersection 4 and 8. And we have here set B. We have 2, 4, 6, and 8. So as you can see, we have 4 and 8 is the intersection, 2, 4, 6, and 8 containing in set B. And we have here set A containing only 0. This number is not present to B. Therefore, this is the difference. So that's it. I hope that you learned something about the operations of sets or sets operations.